What's up, gangsters? I'm on a roll. So, how about the promised part 7 of this ridiculous brough superior adventure? This one's going to be long. Sorry about that, but there's a lot of stuff to catch up on that I was just too unmotivated to do in shorter episodes along the way. Getting this thing to this state of repair, prepare, was a lot. And this video is going to include some CAD and 3D printing stuff that might be useful for you, even if you're not building one of these things. Why you'd be watching this video if you're not building one of these things? Yeah, I don't know. But anyway, it is what it is, and hopefully it's good information. And yeah, let's get to it. Okay, so here is the current state of affairs. There's lots to catch up on. So let me just kind of rewind to where it was still just the swing arm and the main frame sections separate. Ignore these 3D printed parts for the moment. We'll come back to that in just a little bit. All right. And please ignore me bumping into the camera with the brim of my hat. Some things have never changed. So, I guess one thing to point out, let's just start with the really embarrassing thing. Remember this little tab that I talked about right here as not being able to see what it was for, and so deciding very impulsively to just chop it off? Yeah. Well, obviously it's back, and it's good that I was able to find it in the trash can, because what that thing does is it is actually for the bracket or the arm, whatever you want to call it, that keeps the rear brake drum from turning. And I just wasn't really paying attention. It's that blue thing. It's a photo etch part that attaches to the said rear brake drum right here across this sort of part that you can see right there with the rivets sticking up. And I just wasn't really registering that it was there. And the reason that I didn't see it in some photographs is because it's not on all broughs of the time. Some of them had a different type of rear hub, and that part just wasn't there. So, okay, all right, so that clears that up. All right, then it also took me a while to figure out what this arm right here was for, because I couldn't imagine any real reason to have another linkage attached to the swing arm, and it was hard to see in photographs. But I finally did get enough photos that made it clear that what this is has nothing to do actually with the swing arm. It's stationary, and the bottom end of it does not bolt to the swing arm. It's a hanger for the exhaust pipes. And what really made that clear was when I started looking at broughs that had single pipes coming up each side, and there was one of these on each side. So that cleared that up, and it enabled me to go ahead and attach that part. I also had to add the little caps that cover the screw heads on each of these parts of the swing arm. Got all that done. And at that point, it did take quite a bit to get there, but at that point, I was ready to go ahead and attach the swing arm to the front part of the frame. And this fixture really was one of the smartest things I've done, because I was able to keep the swing arm attached to it and everything stay where it was supposed to be, and then get the front part of the frame attached and then soldered. And it was a little bit of a wrestling match. I'd had to do some pinning and some drilling and so forth, but ultimately I got it done. And I'm pretty happy because, as you can see, the cross member for the swing arm is parallel to this cross member of the frame. And, you know, there was a lot of pushing and pulling and twisting and bending and tweaking to get it where I felt like all parts of this frame were going to be going down the road in the same direction. One thing that helped put all this together was the fact that I had soldered this pivoting damper assembly to the top part of the swing arm and to the bottom down here where you can see where those tabs go into the slots. And then that made it pretty easy to put the screw in here and have everything held in place while I soldered this portion to the frame. So all of that is very sturdy, very happy with all of it. Oh, one thing that you'll notice is that while this tab right here is back, that some tabs are missing. And if you're really sharp-eyed, you'll notice that it's these tabs right here. Also on both sides. Okay. Right here. That pair of tabs over there, that's because those are for the rear foot pegs. And I have fully committed to not having the pillion pad on the rear fender and doing away with all of these fender stays except for this one right here, for the last one. And I figured, well, if I'm not going to have those any of the stuff for the passenger, there's no reason to have the passenger pegs or the mounts. And you can see that on some broughs as well, like some of them that were set up for racing. And so I thought, well, that's a great way to not have to deal with those foot pegs anymore. And so that was a pretty easy decision to make. And you can see that while there were 3 bosses for these fender braces, that we're now down to just the one. So all that cleaned up, all that ready to go when I finally attached the swing arm to the frame. Now, as far as the frame itself goes, before I attached the swing arm to it, I finished with the cleanup of the frame here where I had chopped it off and lengthened it, and that really did prove to be the right decision. But one thing that was frustrating, you can see there's a bunch of black super glue right there, and that's because my solder joint kept cracking. It just was not wicking into the joint enough, even though there is a brass pin in there. And so finally I just said, yeah, well, fuck it. And I put some solder in there. Another piece that I added before joining the 2 sub-assemblies is this right here, which is the top mount for the springs. Now, once I did that, and once I had the swing arm in place, and I took a look, I quickly discovered that, said springs no longer fit correctly. They are, hopefully you can see that. Hopefully it'll stay there if I turn loose of it, because it doesn't really have anything to support it. It's about, it's a millimeter or two too short. And, you know, that's just a penalty of putting the whole swing arm together before I attached it to the frame, and then attaching it to the frame the way that I did with everything soldered up. Just tolerance stack up and errors in the construction. And I knew that was a possibility. It's disappointing, but it is what it is. And what I'm going to do is just design and print some little spacers to go in there. And I don't think, anybody will ever really notice that. So anyway, it is what it is. And actually, it's fine because it makes the springs super easy to put in there, which means that I can paint all this and get good coverage inside there before I put the springs on. All right, now the next thing that I put on was this oil tank, and that was pretty straightforward. Got all the holes drilled in it, and put it on there and soldered it in place, and then filed down the joint as best I could, and I'm pretty happy with that, even though if you look at it from the bottom, you can see that it is nothing like straight with the rest of the frame. It's kind of hard to tell on the camera, but yeah, it's out of whack. But the whole thing is out of whack. It just is what it is. So at that point, I went ahead and attached the two sub-assemblies together and started to turn my attention to the next thing, which was getting the drive line figured out. The first thing I had to do was deal with putting the transmission on, and I very quickly discovered that once again the two threads sticking out that MFH gives you on every single screw is not enough to hold this firm for any length of time, and so I've temporarily stuck it in there, or I've got the screw in there, but it's also stuck there with some temporary adhesive. I had this stuff that's for bare metal foils sitting here at the bench, and I just used some of that, and it makes a nice sticky glue joint that I can peel off when the time comes. And then I went ahead and temporarily put the engine cases back in there as well, and started to work on figuring out the whole chain thing. Now, the chain, yes, you'll notice, yep, 3D printed chain that is on the kit rear sprocket, but that has a 3D printed front sprocket. I've been through a bunch of iterations of the chain, and that's why it's broken off, so that I didn't have to keep peeling it off of the rear sprocket and putting it back on. But here's what the whole part looks like, and I'm gonna transition over to CAD later in this video segment and talk about how I designed these and set them up for printing. Looks really good. I'm really happy. It's a little bit beefy for a 1/9 scale 530 chain, but not too worried about it, because it looks, in my opinion, way better than what you get with the kit. And that was my first reason for wanting to do it that way, was just to look better, because these are the photo etch link plates, and there's two problems with these. One is that they're just super thin. It is what it is at scale, and it's not a huge discrepancy, but they are thinner, they look thinner, they just look too thin to me in every example of this thing that I've seen built. The other issue with scale is the diameter of the pins. It's pretty easy to see when you look at the photo etch parts that the ratio of the diameter of the pins to the round portion of the link plate is just way too big. If you look at a picture of a real chain, the pins are just quite a bit smaller. So from that perspective, I wanted to design my own. I just knew that it was going to look better. And then there's the fact that, yeah, I just didn't want to deal with all of this nonsense of hundreds of link plates and, no matter how ingenious this might have been, putting each and every link plate on there and then riveting the pins, yeah, I just didn't want any part of that. I knew that even though it was going to take me several tries to get everything to fit, that it was still going to be faster. So that's what I did. And I will say this. Some people have said that that a lot of vintage bikes used a 600 series chain. If you're not familiar with the way that chain nomenclature works, most modern motorcycles that have a chain use a 500 series chain. And what the 500 means is that the pitch, the distance between each set of pins, is 5/8 of an inch. Yep, sorry, it's in freedom units. I think there's probably a metric designation, but I don't know it. Anyway, that's what a 500 series chain is. A 600 series chain has 3/4 of an inch of pivot, or of pitch. And it could be that on a Brough Superior, it was a 600 series chain. It's impossible for me to know. I haven't been able to find any technical documentation that verifies that. It's only an 1/8 of an inch difference, and at 1/9 scale, yeah, they're going to be pretty close. Now, you heard me say that it's a 530 chain. So what you have is 520, 530, 540, and what that second number dictates is the thickness of the plates and the overall width of the chain. And that's why I said that even though I designed this as a 520, that it ends up looking kind of more like a 530, just because of scale. And it's all good. I'm totally happy. This looks way more realistic than anything else I've seen. Now, the question was, designing it correctly pitched at 1/9 scale, would it fit on the kit sprockets? And the answer, happily, was yeah, and it really was not too bad. The kit sprockets are not really properly shaped, and I had to go in and clean them up a little bit. They needed to be a little pointier, but once I did that, it's relatively straightforward to take this chain and wrap it around the sprocket. Even though the chain doesn't really pivot, it's flexible enough that, well, it's not flexible now. It's had some time to sit here and cure, but at any rate, I was able to wrap it around the sprockets and get everything to pop into place, and worked great. Not bad at all. And that enabled me to start getting it figured out exactly what length it needed to be to mate with the non-movable transmission. And I say that because part of the way that you get the correct tension on the chain here is with the chain tensioners that are in the swing arm back here. You push the rear axle back or move it forward, and that tightens the chain. The other thing, though, is that the transmission is going to be on bolts that allow it to slide back and forth, because you also have to get the correct tension on the primary chain that runs from the crankshaft back to the transmission countershaft. And this obviously does not move on the model. So there was some finagling there, and I'm going to talk about that when I bump over to the discussion in CAD. But bottom line is that once I got it all figured out for the drive chain, then it was time to move on to the primary chain. And again, because I just don't like the way the kit parts look, I decided to design my own clutch basket. And there's another reason for that I'll get into in a second, because with the, I'll come back to it. At any rate, Same type of chain, same pitch, but I had to pull some shenanigans with this weird looking link here at the top to get everything to be the right length. But once it was, then I was able to do the same thing, wrap it around the kit primary sprocket, and everything. There we go. All right, so that's all correctly spaced, and the lateral, everything laterally is the way it should be. The chains are all nice and straight. So, and it took me a bit to get where I was happy with that. And again, I'll talk about the finagling that I had to do when I can show on CAT. Now, to go back to the fact that I wanted more detail in these in the clutch, is because I decided not to, and I decided this early on, that I was not going to have the primary cover like this. I was actually going to trim it back so that about half of the clutch basket was showing, because that's not an uncommon thing with broughs that the young men who rode them had done to customize them. But I very quickly discovered, and I guess I've already thrown it away because, yep, it was junk that didn't fit. But here, let me show you in the instructions. This primary cover attaches to the frame in 3 spots, and when you had 2 of them correctly positioned, the 3rd one just absolutely would not connect. Okay, right here you can see where the primary cover has an attachment point right up there underneath the primary sprocket, and then again right there by the right there underneath the oil tank. It's actually only 2 spots. But bottom line is that that hole in the primary cover was about 2 millimeters from the center of the primary sprocket. So that did, and there was just not going to be an easy way to fix that with the kit part. And since I was already changing the look of it anyway, I decided to also design my own primary cover that looked like some that I had seen in various photos. And this one does actually attach in 3 places. It's got the attachment point under the oil tank, the front one, and then also, as it is on the real thing, at the swing arm pivot. And again, I will show you in CAD all of the finagling that it took to get that to work, but it drops on there pretty well, and I'm happy with the way that it looks. Everything pretty much where it's supposed to be, and you can see all of that cool detail with the clutch and the primary chain, and where it says London on the engine cases, and I'm stoked about that. The other thing you'll notice is that there's been a wash put on here, and that's one of the great things about 3D printing, is that not only can you test how things fit, but you can test things like whether or not your washes are going to flow correctly based on how the printed gaps actually turn out. Now, having said that, even though this wash looks pretty decent, I'm actually not totally happy with it. You can really see it on these parts. It looks okay, but I'm having a hard time getting the slots on those screws and the shape of the screw heads to be correct, because that's just an area that traps uncured resin, and I've experimented with a bunch of different sizes for the slot and the gap between the screw head and the boss, and it's just not working. So I'm thinking that what I may end up doing is redesigning or changing the design so that there's no screw heads, just holes, and then printing the screw heads separately, and then I can just paint them and drop them in, and the color separation and everything will be perfect, and then I'll put the wash on. All these parts, all the other parts are pretty much black. So anyway, so that's that. All right, so the last thing, yeah, almost forgot. Not quite the last thing. Yeah, you'll notice that there is no chain guard. It's actually right here. Now this part I had gone ahead, it's 2 halves. I had gone ahead and assembled it, soldered it together, finished it off, and because the fictitious brace that they had back here that attached to one of the fender stays could no longer be used, since that fender stay is no longer there, I added a brass one that's much more like the real thing that goes down here to just right behind the dropout. So I had this thing on there, and then I discovered that it was not wide enough for the chain. It's going in there now, but only barely, and that's only after a lot of fussing. And I never was able to get it to go on with this attached to the swing arm. And it was soldered right here at this little spot and right there at the swing arm pivot. And all of the fussing around eventually caused this mount to crack. And at that point, I was mad. I just yanked the whole thing off of there and decided to design and print one. And then I started thinking, maybe I won't even put a chain guard on there. Maybe the guy that, owned this brough in 1931 or whenever it was just, doing his own thing and decided he didn't really need a clunky sheet metal chain guard and liked the look of the chain and just decided not to put it on there. That may be my story. And it kind of goes with the other thing that I did, which was I decided to go fully off script with the rear fender. So the way that this fender is supposed to be is, you can see from the side view that it wraps way around the rear wheel, and that it's got this thing here, a brace and a clip, and that is actually the flip stand, I think, that allows you to put the bike up on it so that you could pull the rear wheel off if you need to. But it's got a brace right there, and it's actually, in real life, it's 2 pieces. And it has like some little quick release things that screw into like right there, and then down there on the brace. And this right here shows how that's all supposed to go together. Well, I decided, you know what? I kind of want to do a sort of a bobber. If you don't know, a bobber is basically a style where the rear fender of these bikes was cut off like right there. I decided I didn't want to go that far and that I wanted to cut it off kind of more somewhere down here, where I still had maybe enough room for the license plate bracket, because one thing about bobbers is that the license plate bracket usually ends up getting moved like to the rear axle, and I don't want to do that if I don't have to, because the license plate sticks way out to the side and looks goofy. So I wanted to be able to still keep the license plate holder there, but yet still be able to get the whole rear wheel in there once the fender is permanently attached to the thing. Because, as you can see, the way that they have you do it with it this way is you got to put the rear wheel in there before you put the end of the fender on there, because the fender wraps so far around that there's no way that you're going to get the wheel in there and get the axle into the dropouts and all the things. And so I'm trying to compromise, and I haven't had a chance to put a rear tire on that yet and check it, but that's going to be next once I take this wheel out. And there's something to say about that in a second too. But at any rate, this was just a matter of making a kind of a pin slide thing with some brass tubing to hold that piece in place, and then flipping it over and getting it all soldered up on this side, and then just filing it down and making it look good. And I may still need to go back and fill in these holes. It depends on where the license plate bracket is actually going to end up. But I'm really happy with the way that this ended up looking. I think it's going to be pretty seamless once it's all painted, and it's going to look pretty cool. So that'll be the next thing, is I'm going to pull the rear wheel off and put this on there, and then put the tire on the rim and see if it'll all go together. While I have the rear wheel off, though, one of the things I have to deal with is that, and this is deja vu going back to the front wheel being so crooked, is that I was messing around with this and I actually broke this glue joint on some of the spokes, and this wheel is badly crooked. You may be able to see it, but yeah, you can tell if you look. The rim looks like it's in about the right spot in the swing arm, but look at the rear sprocket. Yeah, it's cockamamie, and the whole thing is just wall-eyed, and I'm gonna have to get that out of there and deal with it. And in preparation for doing that, I have built myself a little bracket / truing stand thing, and printed it that so I can put the rear wheel in there, clamp it down with the rear axle nuts, and then hopefully be able to get it all straightened out. We'll see. All right, so that's all of that. The last thing to point out is that all of this soldering that I did, which honestly has been like one of my favorite things. I mean, I may or may not have decided to do this just so I could do more soldering. It makes me feel like a real metal fabricator like I used to be back in the day. But anyway, one of the things that made all of that easier and even more fun is that I got rid of the Hakko soldering iron that I had bought, because I think, as I was complaining, it did not have an on-off switch. So I gave it to my friend and bought this one, and it definitely does have an on-off switch. And it came with this holder for the iron, and it is super cool. You just reach over here, turn it on, and then you just twist this to dial in the temperature. Thing heats up super fast. It is fantastic. I should have bought this one in the first place, because it was only like 40 bucks more expensive than the one that I had, and way worth it. Because I'm, as I work on this a little bit each day, I'm constantly turning this thing off, turning it back on, and having the switch is just much easier. All right, so let's jump over to the CAD side and go through a few things. I don't want to turn this into like a fully detailed CAD tutorial, but there's a couple of quirks and things to show you about creating this chain and sprockets that are good, because it applies to other things as well. Like, let's say you wanted to create tank tracks or a pattern of rivets or whatever. So the key thing here is going to be using the pattern on path command. And just real quickly, I'm going to just jump over here, make a new thing, and show you just very quickly how that works. All right. So let's just start with an object. We're just going to keep this simple. and we're going to extrude that out. Let's just say that that's like a chain roller or a rivet. And we want to create a path to pattern that on. Okay, so we'll do another sketch in the same plane, and your path can be a straight line, it can be a line and a combination of curves, or it can be a spline curve. We'll do a spline curve because that's just kind of fun. Okay, so there's our spline curve, just an arbitrary one right there. All right, now the way that the pattern on path command works is you access it from the rectangular pattern command, but you select this option, pattern on path, okay? And you can do it with bodies, faces, features, components, and in this case, we're gonna do it with this body that we created right here. And the path is just gonna be this curve. And you can stretch your pattern out for as much of the path as you need. You can add in as many instances as you need. You can, if you click on the little check marks, you can suppress those. And there's different options here for the way it works. And again, I don't want to turn this into a complete tutorial, but that's the fundamental thing with creating a pattern on path. And I think you can already see how that would apply to building a chain and sprockets. And you would think that it would be pretty straightforward, that you would just create a path that represented this entire loop of chain and that you'd be off and running. Unfortunately, it's, while pattern on path is very powerful and very useful, as you'll see, it's not quite that easy, unfortunately, for a couple of reasons. And we're going to get into that. But it is true that the first thing that you should start out with is I created 3 components: the countershaft sprocket, the rear sprocket, and the chain. And the very first thing that I created within this chain is a sketch that defines the chain layout. And this is going to encompass the most important dimensions for this whole thing. And it's important that it be fully defined so that this is easy to manipulate later on, because I guarantee you it ain't going to work the first time. So what you need is the center to center distance of your sprockets, if that's what's happening. And then you need the diameters of, or the radii of, the pitch circles. The pitch circle is the circle that all of the link pins are centered on. And you may ask, okay, well, how do I know that? All right. You can see that right here. You can see where all the link pins are resting on that pitch circle. So all of this stuff is standardized. The dimensions of roller chains, the gears, the sprockets, etc., all of it is standardized, and you can get all that stuff on the old interwebs. The first thing you have to know is what your chain pitch is going to be. And if you just go over here and look at chain dimensions, again, you can find all that stuff. You can down to the very last thing, the thickness of the link plates, the width of the rollers, the pitch, etc. But for now, the single most important thing is the pitch. And as I said before, the pitch of a 500 series chain is 5/8 of an inch. Notice also that you can get your roller widths and all that kind of stuff right here as well. Okay. Now, once you know this pitch distance, then you need to calculate the size of the sprockets. And you can find sprocket calculators all over the place, but the one that I've been using is this. I just Google sprocket size calculator. All right, and this is pretty cool. because what you do is you put in your pitch. So right here, put in 0.625 inches and the number of sprocket teeth. Now, I know the number of sprocket teeth because I counted them off of the kit parts. So let's say that it's 18 teeth, and we just say calculate. Now it's going to give me sprocket diameter. And what that is, as you can see, it's actually this pitch circle diameter, not the overall outside diameter of the sprocket, okay? So 3.599 inches, let's just call it 3.6, scale it down and divide by 9 to get your 1/9 scale answer. And you are back over here at the CAD model where you know what the size and the number of teeth, etc., of this countershaft sprocket is. And that's where, with this sketch, you put in these numbers right here. Okay, so once you've got that figured out, then you can start to build your individual sprockets. And that's the place to start because that's going to dictate the starting position of the first chain link. All right, and the sprocket is relatively straightforward. It can be about as complicated as you want it to be, but basically what I do is I just start with a disc, and then I build in a tooth cutout. And the tooth cutout is where things can get complicated because, again, this is all standardized, and you can find all of the dimensions online that control this tooth cutout profile. But the most important thing is that you're going to have a circle that represents a chain roller, and it's going to lie on that pitch circle. After that, at 1/9 scale, I just basically manipulate these dimensions until it looks pretty good because, 1/9 scale. All right, now once you've got that done, then it's time to just do a radial pattern and get all of your teeth. And then once you get that refined and you're happy with the way that all that looks, you can go on and build the other sprocket. And then it's time to actually start on the chain itself. It's important to make sure when you're building these sprockets, though, that you're easily able to manipulate the sketch that controls the tooth shape so that you can rotate things around, because you have to remember you're picking a single dimension for the distance between the centers of the sprockets, and that could end up changing when you find that things don't fit exactly right, because if you're thinking ahead, you understand that with the pitch of the chain, it has to match exactly with the number of links in order for the chain to come to a perfect, complete loop where the last link pin is exactly centered on the first link pin for it to actually work. And trust me when I say that is probably not going to happen. I mean, if you're working from scratch, you can, and everything is under your control, you can probably do that. But when you're trying to make this thing fit the kit, like I am, and going back to the fact that the rear wheel is movable in the swing arm and the transmission is movable in the frame, but on the kit, some of those things are going to be fixed, you're going to have to kind of do some finagling, all right? So let's skip ahead to the part where we start actually building the chain itself, okay? So I started with the first set of links. And again, you'd like to believe that you can just do this and then it repeat magically all the way around this path. But the problem is that if you do all this as like one body, the orientation between the inner and outer link plates is fixed. And Fusion isn't smart enough to know how to pivot those individual parts to match the path that you've created. So What unfortunately that means is that you're going to have to do this in segments. And there's different ways to approach it. You can start with just the rollers, and you can do all the rollers all the way around to get everything figured out, and that's a pretty good way to do it. And then come back and do the link plates. There's really not a super clean, like one-step thing. And so what you'll end up having is, like the first part of this chain is I did a radial pattern to wrap all the link parts around the sprocket to about where I knew that they were going to need to be. Then you start building more of it, and now I've got a straight section that covers that bit, and then I'm going to connect another radial pattern section there. Now, you would think that what I would do here is just another straight section that gets me the rest of the way, right? Yeah, well, the problem is there's two things. One is it's just not going to work out mathematically because the distance between the two centers is arbitrary. It's not at all related to the actual pitch of the chain. So I'm going to have to play a little bit fast and loose and count on the fact that some of this is not going to be seen when it's all put together, and the fact that there's going to be a split in this chain that allows me to loop it through the swing arm and the frame when I'm actually assembling it, okay? So the next thing that I'm going to do is create a path that represents the bottom portion of the chain, and that's a spline curve where I've incorporated a little bit of chain slack. And this is the kind of thing that could come in if you were doing tank tracks, for example. In reality, there will be just a little bit of slack on this chain. They're never going to be perfectly tight. If they are, you're probably going to break something. But this is where you get a chance to literally just do some shenanigans to make it all work. And so now I have this new path segment, and when I do that, then boom, there we go. Got the beginning of the rest of the chain. It's just the inside links at this point, and then I do a second pattern on top of that to get me the outer link plates. Okay, so that's the basics of how to create the chain and sprockets. But the next thing I want to show you is how to really leverage the power of Fusion and the pattern on path. All right, now, because the next thing I need to do is combine whatever bodies are necessary into a single printable STL file. Right now, all these chain parts, I think, see, there are a shit ton of bodies, and obviously I don't want that, so there's going to be a place like right here where I combine all those into a single body. But I still have, I'm still going to want to print the chain and the countershaft sprocket together. And if I just made the STL file right now and then took that into Lychee or whatever slicer you prefer to use, I would have a lot of work for me because I know that I need to print this chain flat. And the reason is because the head of each link pin is what needs to be the lowest part of the print, or the closest to the build plate. It's actually the highest, given that it's upside down. But anyway, and if I do that in Slicer, there is no pattern on path command. There is no way to relate the center of the support to the center of each link pin. And I would basically just be doing all of that manually. And it would be totally possible, but tedious and slow. And here's the thing. If I change the design even a little bit, all those supports are going to change, and I'm going to be doing all that work again. So wouldn't it be great if I could use the same pattern on path command and the same path in order to create the supports? Well, guess what? You can, in fact, do that because we're going to make a chain support component in this assembly, and in pretty much the same way that we created all of the chain parts we're going to create individual supports. And each and the way this is really a lot simpler than it looks, because you just start with one, and it's just a revolved solid that has the right shape, and you're just going to pattern that thing using the same patterning steps that we did before. And if you need to put a support in a slightly different place because of the configuration of the parts, you just make a copy and you move it and size it, whatever you need to do to it, so that you're saving yourself as much work as possible. So once I have all the supports built, then what I'm going to do is create a raft right there. And then, and that's now all one body, the raft and the supports. And then I'm going to make yet another component where I combine all of the parts into a single print body. And that's going to be the final thing that I will export as an STL file. And you'll recognize that as being the printed parts that I showed you before. Okay, so hopefully that was somehow useful and not too excruciating. The CAD thing, I think, has probably got the most value for a lot of you guys who are doing the fusion and 3D printing stuff. The pattern on path command is really super powerful, but it is also super quirky and can be kind of frustrating. And honestly, I could have done like a whole 30-minute thing just about pattern on path. But yeah, and if you guys want me to, request down in the comments and maybe I will. Anyway, as always, I hope you found it useful, and if you suffered through the whole thing, I appreciate it. And as always, much love.